All right, so we're going to continue on our work here with special right triangles, and there are two special right triangles that we will discuss today: 45, 45, 90, and a 30, 69, 90 right triangles. All right, and you can see that this takes care of standards 18.3 and 18.4. I can find side lengths of triangles using the properties of your 45, 45, 90 triangles and your 30, 60, 90 triangles. So this is going to be Unit 8, Lesson 3, and we're on page 97. So what I want you to do is go ahead and do the opener here. And you can pause the video, flip it back on. We'll see how you do, and then we'll go into the development of the relationships in those two special triangles. All right, so let's see what you did. And I just did the work here on the right-hand side. So if BC is 5, that means AC also has to be 5. Because if angle A and angle B are congruent, we know we have an isosceles right triangle, and the sides opposite of those angles also have to be congruent. So I would have 5 squared plus 5 squared equals AB squared, which means 50 would have been equal to AB squared. So that if I take the square root of both sides, right, now I can then reduce the square root of 50 to 5 root 2. All right, now in a very similar fashion, if both sides are 1, it'd be 1 squared plus 1 squared equals AB squared. So 2 would equal to AB squared, and then I would take the square root, all right, and I get the square root of 2 here. Now, what we were hoping you would see, and it's really a little bit hard to see when you have 1 here, but if I look in the first example here, my two sides are 5, and then my hypotenuse is 5 root 2. All right, if I look at this, right, and it's a little harder here, so I'll just draw it in right here so we can see my two sides are 1, and then my hypotenuse is root 2. Now, this is really the pattern that we want to see here, and I did that on a separate sheet of paper, so let me pull that over here. Right? If we have an isosceles right triangle, what that means is that the two legs are congruent. So I'm going to label them both as A. So we'd have A squared plus A squared equals C squared. Now, if we combine that, A squared plus A squared is 2A squared. And then I would take the square root of both sides, just like we did before when we had integer answers. And then when I look at this, the square root of 2 is just the square root of 2. But then the square root of A squared would just be A, in the same way the square root of 25 would be 5, square root of 9 would be 3. All right, and so what this is telling us is that C is always going to be A times root 2. So the hypotenuse, all right, is always going to be root 2 times larger than whatever side you have in your isosceles right triangle. So if we know this side, we just multiply by root 2 to get to the hypotenuse. Then we can also go in reverse. If we know this side, to go from the hypotenuse to a leg, we divide by root 2. All right. So here is, right, what we have here, right? So we know that this is A, right? This is A. We have an isosceles right triangle. And this is always going to be A root 2, just like that. All right, and I'm make my 2 a little bit better there. All right, and that's the relationship that you will always use. All right, and so when we look at what we have here, right, okay, and we look at our example, all right, notice I always want to know, do I start with a leg or do I start with the hypotenuse? So notice in this case, I start with the leg. Well, if it's a 45, 45, 90, then I know the two legs have to be equal. So this also has to be 2 root 2. Now, x is the hypotenuse. So notice x has to be A root 2, right? So x has to be A root 2. And then once I know what A is, I can just plug it in. And A is our side length. So I can take my side length and plug it in for A here. So that would be 2 root 2 times root 2. And then once again, root 2 times root 2 is root 4. All right. And then the square root of 4 is 2. And so that means that that hypotenuse, right, has to be 4. All right. So once again, if I know the legs, I just multiply them by root 2 to get to the hypotenuse. Now, let's skip down to problem 2 here, and let's go in reverse here. So notice, right, in problem 2 down here at the bottom of our page, we have our 45, 45, 90, right? So if this is x, we know this also has to be x. But notice this time I'm starting, all right, with the hypotenuse. Now, we're still going to use the same relationship here, right? So these have to be A, right? Just like we have A's right here. This has to be equal to A root 2. So I know 6 has to equal to A root 2. And I want to solve for A because the side lengths, all right, in our right triangle here have to be A. And so notice to solve for A here, I have to divide both sides by the square root of 2. just like that, right? Now, this is why we did all the work with radicals before we did this lesson, is because notice now we have the square root of 2 in our denominator. So what we want to do here, all right, is, all right, multiply by root 2 over root 2 and rationalize that denominator like we did in our prior lesson. So I'm going to do that right here. Okay, and so notice my numerator would be 6 times the square root of 2. Root 2 times root 2 is 2. And then once again, we just want to reduce this like a fraction. So 6 divided by 2 is 3. So my final answer is 3 square root of 2. All right, so there's an example of how you start with a side and you go to hypotenuse. How if you start with a hypotenuse, you go to a side. All right, so let's flip and let's go to page 98 and let's look at our 30, 60, 90 triangle. Now, I'm going to develop this relationship for you. All right, so I'm going to do this here on a separate sheet of paper. So if you want, you can draw this and just copy this and add this somewhere in your notes. All right, if you want to, or you can then copy it. We'll transfer everything to here in just a moment. All right, so now, here's where the 30, 60, 90 relationship comes from. It comes from starting with an equilateral triangle. And so notice, if this is an equilateral triangle, that means all of the sides are the same. So I'm going to label them all A. Okay, now I have to create, all right, a 30, 60, 90 triangle. Now the way we do that if we start with an equilateral triangle is I drop what we call an altitude from my vertex angle here. All right, and that's perpendicular. All right, let me refocus here. All right, to the opposite side here. And notice if we have an equilateral triangle, we know all the angles have to be 60. So this was 60, this was 60. This whole angle up here is 60. But if I drop this altitude, notice if this is 60 and this is 90, and we know the altitude is congruent to itself, we know that this triangle on the left is congruent to the triangle on the right, which means, right, by angle, angle, side, which means that the two angles up here have to be congruent to each other. Well, this angle to start with had to be 60, and now we have it cut in half, right, because it's got to be equal to each other. So that means that this is 30. This is 30. That means this is 60. This is 60. All right, now we're getting there, right? So now when I look at what we have here, right, when I look at, all right, our triangle. So once again, that triangle on the left is congruent to the triangle on the right. That means then that this piece, right, has to be congruent to this piece. All right, so now when I look at this triangle, right, the whole thing was A. So that means that this is 1/2 A, and this is 1/2 A. All right. So notice the only thing we're missing in this 30, 60, 90 triangle, all right, is the side opposite 60. So the side opposite 90 is A. The side opposite 30 is 1/2 A. And so we need to figure out, okay, we want to get this in terms of A as well. So what we're going to do now is, all right, the Pythagorean theorem. All right, because we know we'd have 1/2 A squared plus x squared equals 2A squared. All right, and so notice A has to be C because it's the one opposite. All right, so notice if I square this, this would be 1/4 A squared plus x squared equals A squared. I would subtract this 1/4 A squared, all right, from both sides. And that would give me x squared equals, now remember this is 1, right? So this is 1A squared. So 1 minus 1/4, all right, would be 3/4 A squared. All right, so now when I take the square root of both sides to solve for this, I get x equals the square root of 3/4 A squared. Now let's look at perfect squares here. Right, the square root of 3 is the square root of 3. The square root of 4 is 2, all right, and then the square root of A squared is just A. Now, if we look at what we have here, all right, if we look at what we have here, notice that I can rewrite this. This is really, right, root 3 times, and I can just write this as A over 2. Well, A over 2 is really this side here, right? Because if I take 1/2 A, I could really write that as A over 2. All right. So notice the side opposite 60 is root 3 times larger, all right, then the side opposite 30. So that's an A, not an I. So there we go, A. All right. Now, and let's just summarize here. So now when I look, this is 1/2 A, this is A. So that means this side is always twice as big as the side opposite 30. So when I transfer this here, I'm just going to change the notation to make it a little bit easier. All right, so when we label our triangle here, okay, let's say this is 30 degrees here, and let's say that this is 60 degrees here. All right. So just to make it a little bit easier to work with our equations, I'm going to let the side opposite 30, all right, be B. Okay? All right? Now, here's what we know from the relationship is, right, the side opposite 30, all right, is 1/2 A. So the hypotenuse is always going to be twice as big as the side opposite 30. So then the hypotenuse would be 2B. So it's going to be twice as large. And then from what we see here, A over 2 is the side opposite 30. And so the side X is the side opposite 60. It's always going to be √3 times bigger than the side opposite 30. So we're going to label that as, all right, B times √3. Okay, so that's your relationships, right? So the side opposite 30 is B. Side opposite, the hypotenuse is going to be twice as large. And the side opposite 60, all right, is going to be B √3. All right, so now let's look at what we have here. So now, when I look at my figure, it's always, once again, what do I start with? Which side do I start with? So we have our 30, 60, 90 because we have a right angle here. We have 60 degrees here. And then this angle is 30. And notice we're starting with the hypotenuse, which is 16. So if I come back to my figure here, the hypotenuse, all right, is going to be equal to 2B. So 16 is equal to 2B. So then if I solve for B, I can divide both sides by 2. And that says that B is equal to 8. Now B, all right, the side that is 1/2 the hypotenuse is always opposite 30. So in my picture here, that would be Y. So that means that Y has to be equal to 8. Now that means the last side I need to find is X. And X is the side opposite 60. Well, the side opposite 60 is B √3. So that means X equals to B √3. Well, we know B is 8, so I can just drop that in. So that would be 8 √3, just like that. Okay, let's look at one more example together. So let's look at number 6 here at the bottom of the page. And once again, it's all about figuring out what triangle do I have and then what information am I starting with. So once again, here's 90, 60, and here is 30. So notice this time I'm starting with the side opposite 30. Or excuse me, side opposite 60, right? So the side opposite 60 is 5 √3, and we know from our diagram that that has to equal to B √3. So notice now when I look at this, I can solve for B by dividing both sides by √3. All right, so 5 √3 divided by √3, that would leave us 5. So that means B is equal to 5. So now when I start looking at my other relationships, notice Y is the side opposite 30. So that means Y is equal to B. Okay, well, B is 5, so that means Y has to be 5. All right. Now, X is the side opposite the right angle. That means it's the hypotenuse. So X has to be 2B. Well, B is 5, so X has to equal to 2 times 5. So X is equal to 10. All right, so there you go, my friends. So try to wrap up the rest of this lesson. Let me know if you have questions, and I will see you next time when we talk about some other trig relationships.